All right, here's your notes over or your homework over targets 12 and 13. So remember on target 12, what we're doing is finding f of g of x and g of f of x, and we are going to see if they both simplify to x, and if they do, they're inverse functions. If it doesn't, they are not. So I'm going to start by evaluating f of g of x. So I'm going to plug in g of x to the f function. So the f function is 2x minus 4. I'm going to take out the x, and I'm going to replace it with whatever g of x is. So negative 3 halves x, I didn't leave myself enough room, plus 15 halves. I'm going to scoot this down a little bit. Negative 3 over 2x plus 15 over 2. And then I'm not going to forget to rewrite that minus 4. All right, so now I'm going to distribute. So when I distribute the 2 times negative 3 over 2 is negative 3x. 2 times 15 over 2 is 15. And then minus 4. So when I simplify that, that's negative 3x plus 11. This does not equal x, so I actually don't even need to go any further on this problem. And these are not inverse functions. So as soon as you see it doesn't simplify to just x, you can stop. All right, moving on to, I don't know why it says number 4. Moving on to the next problem. We're going to do f of g of x, which means we're going to start with the g function. I'm going to write that out. So 3/7 x minus 15/7. I'm going to take out the x and replace it with whatever g of x is. So 5 plus 7 over 3x. All right, now multiplying or distributing, 3 over 7 times 5 is going to give me 15 over 7. I'm going to leave it as a fraction. And then 3 over 7 times 7 over 3x is just going to be 1x minus 15 over 7. So if I simplify that, that does just give me x. So I'm going to keep going on this problem because these might be inverse functions. So now I'm going to do the opposite. I'm going to put g on the outside, and I'm going to plug in the f of x function. So starting with g of x, that's the 5 plus 7/3 x. I'm going to take the x out and replace it with f of x, so 3 over 7 x minus 15 over 7. And I'm going to simplify this. So the 5 is going to stay where it is for right now. I'm going to distribute the 7/3, so 7 over 3 times 3 over 7x is just x. And then 7/3 times a negative 15 over 7 is going to be a negative 5. And then that simplifies to x as well. So that means that these are inverse functions. All right, moving on to our next one. We're going to start with f of g of x. So f, and I'm going to plug in g of x. So I'm going to write the f of x function to start off with. I'm going to replace the x with whatever g of x says, which is just negative 2x. And now I'm going to simplify. So 1/2 times negative 2x would be negative 1x. And then that would be minus 3 over 2. Notice that that does not simplify to just x. So whenever you see that it doesn't simplify to just x, you can stop and say they are not inverse functions. So let's test out this last problem, see if we have inverse functions here. So same method, just new numbers. I start with f of g of x, which means I'm going to write the f of x function. But I'm going to take out the x and replace it with g of x. So all I have to do here is multiply negative 3 over 5 and negative 5 over 3. Since those are reciprocals, they equal 1x. So that's good. So now I have to go the opposite way. I have to test g of f of x, which means I'm going to start with the g function, and I'm going to plug in f of x for x. So starting with the g function, I'm going to take out this x, and I'm going to replace it with f of x. So this time I'm doing negative 5 over 3 times negative 3 over 5, which equals a positive 1x. So whether I did f of g of x or g of f of x, they both simplified to just x. So these are inverse functions. And again, just giving you some throwback information. That means if I were to graph these, they would be a reflection in the line y equals x, that diagonal line. And also if I were to make a table, the x and y values would be flipped. So then on our last target for the unit, you guys are actually finding the inverse function. So we have 3 steps that we go through. The first step is to replace f of x with y. The second step is to switch x and y. And the last step is to get y by itself. So I'm going to add 2. So that would be x plus 2 equals y. And then I always add in this last step where we use our function notation to say our answer is the inverse of f of x. So again, just going back to your last target, you should be able to do the composition of functions with your original and your answer, and you should simplify to x in both cases. So same 3 steps. Replace f of x with y. Switch x and y. And then solve for y. So I'm going to subtract 5/4. I'm going to leave it as a fraction. And now to get y by itself, I could divide by 1/4, but instead of dividing by a fraction, you can multiply by the reciprocal, which would be positive 4. Make sure you multiply everything over here on the left by a positive 4, so 4x, and that would actually just be minus 5 when you distribute. And then writing our final answer in our function notation. The inverse of f of x is equal to 4x minus 5. All right, number 7 looks kind of crazy because it's this big fraction, so let's see how that plays out. Let's replace f of x with y, and then switch x and y. And then remember, we're trying to get y by itself, so we have to get rid of this divided by 5. So I'm going to multiply both sides by 5. So that's 5x equals 20 minus y. And then getting y by itself, I'm going to subtract 20. So I have 5x minus 20 equals negative y. And I still have to divide by negative 1. So 5 divided by negative 1 is negative 5x. Negative 20 divided by negative 1 is positive 20. And then let's write our answer in our function notation. All right, last problem. Same steps, just new numbers. So replace f of x with y. Switch x and y. And get y by itself. So I'm going to add 20. So x plus 20 equals 5y. And then divide by 5. So that would be 1/5 x. 20 divided by 5 is 4. And then rewriting our final answer. And that is your last target homework for Unit 7. Only one more unit.